Good morning. Today we are going to continue our presentation about ArcGIS 2021 series of products, and we will start with ArcGIS Enterprise. ArcGIS Enterprise is a comprehensive geospatial enterprise system that users implement in their own server rooms or deploying on infrastructure providers like Amazon, Azure, or similar. In a couple of weeks, sometime in May, Esri will release a latest version of ArcGIS Enterprise. And it will have a lot of new features. My colleague Nils will introduce those in more details. The things I would like to emphasize are ability to change mapping engine to faster and better quality ArcGIS Pro engine, better security, usability, and many, many more. And if I'm allowed to pick one big thing, it's a two-way distributed collaboration, where both collaborating parties can edit the same distributed data layers, and changes are traveling in both directions. What does it mean? We can have 1, 2, 3, 4, or unlimited number of organizations interconnected together who are editing their own databases, but exchanging data via web services. In a way, you can have changes traveling in such way that everyone have the same set of truth. For those of you who are running very, very large ArcGIS Enterprise installations, ArcGIS Enterprise on Kubernetes is a new cloud-native deployment option designed to optimize scalability, resilience, and maintainability. It leverages many of the advantages of a cloud computing, like container architecture and microservices, distributing them to scale out, easier maintenance, upgradability, and so on. It's a new version of ArcGIS Enterprise written from the ground up. For those who are not familiar with the Kubernetes, think it as about another operating system, cloud operating system, ArcGIS Enterprise is running on, besides existing Windows or Linux. Esri will not pressure anyone to move away from the current architecture on Windows or on Linux. And Esri will continue to support Windows and Linux as before. Now I would like to ask Nils to demonstrate what he likes most about latest version of ArcGIS Enterprise. Nils?
Hello to everyone. I will be introducing you to the ArcGIS Enterprise solution and give an overview about what's new in the version 10.9. I will start with some use case scenarios and application examples to give a general idea about the capabilities and benefits of ArcGIS Enterprise. I will start the demo with the public application from Estonian Transport Administration. Application itself is called SmartSea. ArcGIS Enterprise lets you use and publish real-time data and big data. Here you can see live ships AIS data stream where constantly hundreds of points are coming in, being analyzed and visualized in a web app builder application. In background, all the data is stored for later use in big data store, which can be then analyzed and visualized. We have already billions of records in the database for different layers. Also, you can see an integration here with the public application of marine traffic by opening one pop-up and clicking the ship picture. We get additional information about this ship from the marine traffic portal. Let's move forward. Of course, 3D. ArcGIS Enterprise will let you publish your 3D content as a service and use these services easily in web applications. This example is from Tallinn City, who have published its 3D twin by using ArcGIS Enterprise capabilities. Multi-patch for the entire city, detailed textures, different city furnitures, objects, all combined to a fast, smooth, 3D experience with different functional web-based toolsets and integrations. Next two examples are from Tartu City and built with new Experience Builder technology for creating functional and fast web applications with different toolsets which are part of ArcGIS Enterprise 10.9. Tartu City has published its architectural competitions through geospatial story maps. You can find here current and historical competitions, and by clicking on a specific competition you get here extra information about this and the location where it's been held. Second Experience Builder example from Tartu City is created for Tartu cemeteries. It is possible to search the existing graveyard information about the people and locations, or even see the information about today's funerals and where they are located. Next, I will show you two examples how you can create custom look and feel applications with your own functionality on top of ArcGIS Enterprise services, Central Enterprise Geodatabase and ArcGIS Development APIs. First example is from Estonian Transport Administration, who has created a digital twin of Estonian roads. This example shows you how ArcGIS developer tools will give you all the powerful capabilities to customize the user interface, add your workflows, and integrate your application with other data sources. For example, we can see that the integration has been made with waste data, weather data, and road conditions, etc., all integrated with central roads datasets. Second example about the custom application is about maritime safety. Also another good example how you can put your GIS to use for wider audience with the help of ArcGIS Enterprise. Maritime navigation warnings are published and visualized with related information in this portal. Through admin interface, maritime people can insert the warnings, and these are sent out with emails and published here in GeoPortal. For example, we can see that there has some research task made in the Pärnu River. And to summarize all your apps and maps you have created with the help of ArcGIS Enterprise, you can present them all together with standard ArcGIS Enterprise site solution. For example, Rae municipality from Estonia has gathered all the applications to this easily customizable portal with their own branding and layout requirements. There are different school maps, road maintenance apps, tourism galleries, etc. For example, they have this nice map where they have analyzed the noise pollution in their municipality area, and all locals can investigate the situation in their own home area. So from here, I will move forward with technical demos about what's new in ArcGIS Enterprise, and will start with showing you how easy it is to create and customize this kind of ArcGIS Enterprise sites portal, as Rae municipality and many other organizations already are using. So, I have here opened the site's configuration page where I can create my portal by drag and drop method, configuring, and don't need any coding to do. Let's go here and add us a new widget, gallery widget, and let's set the group from where we pull the data from. So let's search for builds group and add it and select it. Now from 10.9 you can set the visibility, restrict the user rights for every single section of your portal. For example, here we can set that this section is only visible to certain group, and the people who are in that group can access this. So now we can save this information we can publish this draft, and by going to another browser, you see that when I'm signed in, then I am able to see this gallery, but when I sign out, then publicly no gallery is shown. Let's move forward. Let's talk about a little bit security and maintenance new adjustments. For that, I will go to my portal, my organization, and select the settings. And under the settings, I will show you the security tab. So first thing I will point out for you is the possibility to use access notice to give your users information when they are accessing the portal, or for example information banners. This means I can set the banner active, switch it on, for example to notice people about the maintenance tasks. Save, and now if I scroll up, you see that everyone can see the information that we will have maintenance on weekend. Okay, let's go back, let's turn this off. And about new capabilities, then I must mention that now you are able to configure the email settings from your portal user interface. This means that users are able now to reset their passwords to email workflows, and administrators can get different notifications about security, about disk usage, etc. And if you have configured these settings, then you are able now to use multifactorial authentication. This means you can use extra layer of security. By switching this on, users can enable the security, double security with their smartphones, and they can confirm the login from the smartphones. So this is one. So this is the thing probably you would like to enable from the 10.9. Another thing is that from now on, users can use external user accounts to log into portals. What does it mean? ArcGIS Enterprise supports OpenID Connect user accounts. For example, it can be Okta accounts, Oracle accounts, even eBay accounts. And I have enabled here a Google account. And to demonstrate that how it works, I will open another browser. I will open a page where I'm not signed in, and I can sign in here. And to sign in, I can choose the OpenID account login. I can choose my Google account. I can log in. And now my account is automatically created to this portal with the default user rights that have been set by administrators, and I can start using the portal by just logging in with my Google account or some other Connect ID account that you have configured. And here is the page, and I am logging. So with this, I will conclude my presentation at the moment. ArcGIS Enterprise 10.9 has many other new capabilities that will give you new extra functionality and adjustments. Please reach out to your local Esri distributor for extra information. Thank you for watching and have a pleasant conference.
Okay, thank you, Nils. Now we are moving to data management section. Data management is another fundamental aspect of enterprise GIS. Esri is advancing the tools, workflows, and data models, extending new industry geodatabase models like utility network for utilities and telecoms, based on changing requirements for those industries like parcel data model to manage parcels, improving the editing tools. Esri also expanding the support for new database management systems and continue to evaluate support for other database as a service offerings in a future ArcGIS releases. What I would like to emphasize here, it's a use of web services. Traditionally, ArcGIS used to work with database directly in order to edit the data, perform topological editing, and so on. And this is no longer the case. You can have versioning as a web service. You can have topological editing as a service. You can edit utility network relationship using services. And it opens exciting new capabilities to work from anywhere, from any device. Either it's a desktop application as ArcGIS Pro for heavy editing, or web browser application for simple editing, or mobile app for data collection. No matter if you're working from home, from office, your summer house, or from the beach, GIS web services made it happen. Now I would like to run a video prepared by my colleague Mindaugas to show how web services architecture is used to allow gas utility network editing on desktop or using it on the web. Mindaugas will join us lively on a Q&A session.
Today I will introduce you with the utility network. It's a new technology which supersedes geometric network, and I will run some sample demonstration on gas distribution pipeline of Marijampolė city. Utility network is based on new technology which uses ArcGIS services instead of direct connection to database. You can see one of the layer's source properties, and you see the source is the URL of feature service. Let's take a look at ArcGIS manager perspective. So we have one of the feature services here, and you can see already familiar capabilities like feature access, and there are also new capabilities like utility network diagrams, and new branch version management capabilities for our feature server. So these capabilities are exposed as new REST endpoints here. We'll demonstrate a short editing workflow using new branch versioning technology, which is very similar, you already know from ArcGIS Desktop, ArcMap. I will create a new editing version. We'll add polyline and annotation layers as my data source. In ArcGIS Pro project, I have predefined some templates for to speed up my data capture. Here you can see an inlet pipeline with two customers, one at the middle and one at the end. I will select the main inlet CAD feature as a selection. Then I can make a simple copy and paste operation into one of my templates. So in one click, I will paste CAD feature into ArcGIS pipeline with a plastic material and diameter of 40 millimeters. So in one click, I have feature transferred from CAD to ArcGIS. Here you can see the line. Next step is to add customer meter with a pressure regulator in one asset. Schematically, you can see here one assembly with a meter, a gas pressure regulator, and a tap. As a final step, I will create some features manually, digitizing over CAD layer. So we'll choose pipeline and previously demonstrated meter setting as one assembly that consists of meter container itself with a pipeline and tap and pressure regulator in this one unit. We'll finish that customer inlet completely, connecting a low pressure pipeline at the end of the gas regulator. It is the outlet of a regulator, so we'll also add some tap, internal pipeline, and finally we'll place customer integration point. And during all my editing workflow, you maybe noticed those blue polygons generating during my edit operation. This is edit and validation tracking that is included in utility network. I can see here a red one polygon indicating an error. So inspecting the status of it, I found that I forgot to place outlet port of a gas regulator, as it has incoming and outgoing connectivity ports. So fix this issue, apply edits, and revalidate my data. This guarantees the data consistency. Another nice feature to mention in utility network is diagram functionality. It's like previously schematic extension capability already built in utility network. I am picking one of the predefined diagram templates and generating a new one from my selection. Also, I can place flag on the diagram and choose different layout and regenerate diagram to my needs. One of utility network strengths is that objects can be traced in a different manner in different types. Let's say here we have a cathodic protection rectifier connected with a cathodic protection cable to the steel gas pipeline. So we can trace gas network not only by gas flow but also by conductivity, perform conductivity trace on the gas network, specifying different subnetworks and performing trace as usual. As a result, we can see selected pipeline where electricity can flow through steel pipeline. Here we see not selected some segments, and if we identify them, the reason where we stopped the trace is that our pipeline material is plastic. ArcGIS Enterprise Web utility network can be used with minor customizations in Web Application Builder, providing some widgets. This functionality can be used in web applications as well. Here you see an example of utility network gas trace separate widget where you can place flags on the network, choose one of the predefined trace tasks. As in this example, we are tracing isolation valve. As a result, we have a selected feature, isolation valve, that needs to be cut off in case of gas accident. From selected cut-off region, we can generate schema the same manner as we previously performed in ArcGIS environment. So we can choose one of the predefined templates. Functionality is very similar to ArcGIS Pro application, where we can place start or end points on diagram features, choose different layout algorithm as you see in this example, and regenerate schema to new layout.
Okay, thank you, Mindaugas. That was very, very interesting, and it paves road to creating digital twins in utilities. As you see, information can be managed in 2D. The same information that Mindaugas was showing can be visualized in 3D as well. Let's move to real time. And another dimension of GIS that is rapidly changing is a real-time visualization and analytics. This is all about integrating sensor network and Internet of Things data as GIS layers into the system. It could be moving vehicles or airplanes or ships, or IoT measurements of various types like water pressure sensors, radiation measurement devices, or metering devices, whatever it takes. Esri has been supporting this capability with extensions to ArcGIS Enterprise, ArcGIS GeoEvent Server, and GeoAnalytics Server. Recently, Esri introduced processing of real-time data as an extension to ArcGIS Online with a new capability called ArcGIS Analytics for IoT. This is a completely cloud-based solution, so you can analyze your stream data on maps and dashboards, identify temporal patterns, and extract location-based intelligence, all while working at a scale in Esri Geospatial Cloud. This is important because it greatly reduces the time between measuring and analysis and decision-making, and you don't have to worry about running the infrastructure to support it. Hi, Markus. I know you speak IoT language. Can you show how real-time analytics is being applied in Estonia? Markus, we don't hear you. Not yet.
Not yet?
Yes.
Can we... Okay, can you hear me now properly or not? Okay, great. Okay, so ArcGIS GeoEvent Server is Esri's solution for real-time mapping and analytics. With it, you can track moving assets or process data streams from stationary sensors and even social media feeds. It allows you to focus on the events that are crucial to your operations. So in this short demonstration, I will briefly introduce to you how we integrated a GeoEvent Server for the Estonian Transportation Administration to track maritime operations in Estonian coastal waters. I will switch now to the front end of our application. So this is a web application that we built for our customer. And in here, you can see moving ships, for example, as these triangles. You can click on the ships, you will see a name, ship type, or a direction. Additionally, when you zoom in, you will find also anchor areas or harbor areas. Now, in the back end of this, ArcGIS GeoEvent Server is running. And I will switch now to a demo GeoEvent Server session. And here in the graphical user interface called ArcGIS GeoEvent Manager, you have an overview of all the GeoEvent services that you are running, the inputs and outputs that you have. You can see how many events have been processed, at which rate, and it's also possible to stop and start services. If you would like, you can see here that I have two inputs running. So one is the AIS messages, so the ship positions that are coming in at a rate of roughly 28 messages per second. I could easily add another input. And once I do this in ArcGIS GeoEvent Manager, I have quite a range of input connectors to choose from. I can use feature services or utilize WebSockets, UDP, TCP, or even pull data from HTTP or various or different APIs. When I click on one of these GeoEvent services, or this GeoEvent service that I created for this demo, this is how it looks like. On the left, in green, you can see the input that I mentioned earlier. Then next to it is a filter. We are filtering only ships that are in a certain area of interest. Then next is a processor called Field Mapper, which is basically just mapping our input fields to our desired output fields. And then in blue, you can see the output, a streaming service. Now, it is really easy to just add another processor. You can just drag and drop it from your new elements section. And these processors are simple but powerful geoprocessing tools that do these operations on the fly. You have quite a range of processors to choose from. You can create buffers on the fly. You can calculate range fans. You can enrich your data with additional data. But in my case, I would like to know when a ship is entering a certain area, I would like to be notified. So I will choose the incident detector. I will give this processor a name and name of the incident, ship, enter bay. Then I will define my opening condition as the geometry, so the coordinates of a ship entering a predefined geofence called Tallinn Bay. I will click OK, select the correct incident type for this application, click OK. Then I can connect this directly to my stream. And now I have, again, the option to select different output connectors. I could write to a feature service, to a big data store, again, UDP, HTTP, quite a selection here. However, I would like to use a predefined one to write to UDP. So I'll just drag and drop this over here, connect this, then I will publish the service, also start my output. And now I should see events coming in. Currently, that's not happening. Well, okay, that's just, I've been having some network issues before. Anyway, I will continue. So yeah, you could also choose to send directly an email or an SMS once a ship is entering your area. So in our live environment, we have several more GeoEvent servers running, processing a lot more data. And since we installed this service, we have basically processed more than 1 billion events. And we also created for our customer, the Estonian Transportation Administration, dashboards to keep track of these operations. So for example, this one here, where you can see the historical situation of how many ships are in Estonian waters over time, or how the occupation of different harbors is, or anchor areas. As I mentioned earlier, you can write all this to a big data store, and that's what we are doing. We store in our database roughly 1 billion data points. So if we switch now to ArcGIS Pro, it is possible to integrate your data into ArcGIS Pro really easily by just adding the feature service. And this is how it will look like when you do this. You have this binned view that is showing you where the colors are representing the count of events per hexagon. Once you zoom in a bit more and refresh, you will see all the individual events. And you can just utilize the functionality of ArcGIS Pro and select a different definition query. For example, I would like to just see a ship track of a certain ship for a certain time interval, and I can just use a different definition query. And then ArcGIS Pro also enables you to create graphs. For example, this one here, where you would see the speed of this certain ship over a selected time interval. So I hope that this short demonstration gave you an introduction of what you can do with GeoEvent Server. And yeah, thank you and goodbye.
Thank you, Markus. You see how it's easy to integrate real-time data into ArcGIS, analyze it, and not only make historical observations, but based on this, you can make predictions what might happen in the future. From world of IoT, let's switch to imagery. In this part of the imagery and remote sensing, we can think about ArcGIS as a complete platform that supports these capabilities with hundreds of tools and innovations and workflows. We fall into 4 big categories. Starting with the image management, Esri provides ready-to-use workflows, the ability to store and manage all types of formats of the imagery, and ready-to-use content through ArcGIS Online, as you saw on first day of a conference. ArcGIS also supports map making like orthomapping and feature extraction from imagery, coming from the drones or satellites that we are going to show a little bit later. It also provides tools for doing high-end analytics, classification, segmentation, all the things that image processing peoples do. The 4th category is exploration and visualization. And to highlight one aspect of this is ArcGIS Excalibur, is a web-based tool that allows to use oriented imagery from satellites for image analysis. ArcGIS systems and applications becoming more increasingly n-dimensional in their implementations. It has become increasingly important for ArcGIS to evolve accordingly. Given that significant amount of 3D content is created from imagery and LiDAR point clouds, ArcGIS now is able to provide the best technology for orthomapping and 3D content generation from imagery and LiDAR. Now Tadas will show the quality of a mesh produced with recently acquired, Esri acquired product called nFrames and how it can be used. Tadas, are you ready?
I'm ready. Thank you, Vytautas. Good morning. So, last year, Esri has acquired nFrames, an innovative Germany-based company that specializes in 3D reconstruction from imagery. nFrames products are used in professional photogrammetry workflows and are designed for large-scale projects ranging from city to countrywide. So let's see an example of a mesh that was created using nFrames technology. So this mesh comes from Munich, a city in Germany, and as you'll notice, it is quite detailed. So even when we look in closed spaces, such as between buildings, you'll notice we still have quite a lot of details that have been captured. Since nFrames became a part of our ArcGIS platform, Esri integrates parts of this technology to other products, such as Drone to Map and SiteScan for ArcGIS. So now you'll be able to make even better quality meshes, true orthos, as well as better quality point clouds. So this mesh is nice to look at. However, can we make it more informative? And the answer is yes. we can use underlying feature services to attribute different parts of the mesh. So in this case, I'm using a building feature service. So if I click on a building on the mesh, you'll notice it is highlighted, and we also get some attribute information. In addition to that, we can also modify meshes. Mesh modification tools are available in ArcGIS Pro, but you can also use them in ArcGIS API for JavaScript. So let's say I wanted to flatten an area, like this construction site here. So what I can do, I can choose a replace tool, draw a polygon around the area, and then this area becomes flattened. So this application also allows me to use my own 3D models to place them in the scene based on GLTF format. So let me add a model that I've created with Esri City Engine. So as you can see, I can modify this model. I can move it around, rotate it. I can make it smaller or bigger, and just fit it in the scene and see how well it looks in the overall context. So, as you saw, using ArcGIS platform tools, you can create high-quality meshes, attribute these meshes, and then modify them as you like. Thank you.
Thank you, Tadas. On a day one presentation, I heard Estonian land board have their own plane to collect imagery and LiDAR. I believe using this technology Tadas just showed, they can easily process the data they have and have Estonia 3D in color. How many of you try to collect data using a drone? When we talk about drone mapping, we are talking about flight planning in order to get best quality data, performing data collection and processing, which is a kind of heavy task, and then getting it ready to create 2D and 3D data products that you can use in your own GIS in web or enterprise or on mobile or on desktop. Esri have a couple solutions for this. One is Drone to Map, which provides complete and simplified workflow to process drone imagery. And the other one is SiteScan, which provides a complete end-to-end cloud-based solution or software as a service workflow for integrating drones into your operations. SiteScan enables users to complete drone flight planning and imagery processing in the cloud and sharing result in a cloud environment almost immediately. As we cannot perform a drone flight in the studio, Kęstutis and Erikas prepared a video how we are managing drone data collection using SiteScan for ArcGIS.
Firstly, you have to plan a flight mission and create a project at the office. When arrived to the site, choose a suitable place for drone operation and prepare drone for flight mission. If additional accuracy is necessary, measure at least 3 ground control points with the GPS receiver at the working area. Depending on the case, you can choose flight method from area or crosshatch surveying, perimeter or vertical scanning, and set up mission parameters. On the screen, you can draw a flight territory and view flight trajectory in 2D or 3D views. Finally, enter flight altitude, camera angle, and mission is uploading to the drone. Drone fully automatically take off and start a mission. While drone is collecting data according to the parameter set, you can see flight trajectory, photo capture position, and camera view on a screen. Also, you can see battery status and other flight parameters in real time. After mission, drone returning home. And mission is successfully completed. All data is downloading from drone to SiteScan application and uploading directly to a cloud for data processing. While data processing is in progress, you can make another flight. When data processing is completed, all results included orthophoto, DTM, DSM, point cloud, or 3D mesh can be inspected in SiteScan web application. Also, in a map view, you can compare results captured at different times. In a browser, you can inspect all objects from different angles, mark annotation in separate photos, measuring lines, heights, areas, and volumes. Also, view height profiles and generate reports. All processed data and other information can be shared with other users in ArcGIS Online 3D scene or uploaded to ArcGIS Pro. The results can be used for further analysis, monitoring surface changes, or using directly in story maps to present results as a report for public or inside your organization.
Thank you, Kęstutis. Thank you, Erikas. As you can see, it's quite an easy task, and even you don't have a drone pilot license, which is obligatory nowadays. I believe as we will see presentation from Latvia, even without a license you can fly it, unless it is forbidden. It's generally accepted that imagery should be taken looking straight down to the ground, like a traditional satellite imagery, airborne imagery, drone imagery, and be visualized on a map and incorporated into your GIS. Other imagery, however, is much more difficult to visualize and incorporate into your GIS. Such nadir-oriented imagery includes oblique, bubble, street side, or inspection imagery, among others. Oriented imagery from Esri solves this problem, providing a solution for mapping, visualizing, and exploring imagery that's taken from any angle. You've seen Vilnius, Tallinn already using oblique photos to look at the ground, at the angled view. Let's see if Tadas is going to show us something different. Tadas.
Definitely, I will. So, in the following examples, I would like to show you how we used and combined oriented imagery together with mesh and LiDAR data to create 2D and 3D applications. I would like to thank Vilniaus Planas for providing the data and for Esri for developing the applications. So let's start with a simple 2D application. So in this application, if I click anywhere on the map, it will find me the best photo for that specific place where I clicked on. In this case, we're working with 360-degree photos, so that means that I can look in all directions. On the map, you'll notice we have this dynamic indicator, which shows us direction we're looking at, as well as the field of view. Using this oriented imagery window, I can travel between camera locations. So for example, I can travel to a location on a street corner, let's say here. We also have measurement tools. So for example, I can measure objects in the imagery. So let's measure the height of this object here. It's also possible to overlay GIS layers on top of imagery. So let's say I wanted to overlay streets. So I have street feature service, and you can see how it overlays on top of the imagery. In addition to that, we can edit feature services. So let's say I wanted to collect manholes, and I can see 2 manholes here, and I actually have a editable point feature service. So I just need to mark the manholes on the imagery. And what you'll notice that these points also appear on the map. So that means that I have updated my feature service. It's also possible to use oriented imagery in 3D applications. And here's one such application. Once again, we're using data from Vilniaus Planas, and this is mesh data. We also have street level LiDAR data. So let me turn it on. In 3D applications, we can superimpose 3D data on top of the imagery. So let me show you how it looks. So in this case, I'm superimposing the street level LiDAR data on top of imagery. And you can see how well these 2 data sets align. So even if we zoom into a building corner here, you can see that they almost align perfectly. So when I'm in this superimposed view, I can also take measurements. So for example, I can measure distances. So these are the ArcGIS-oriented imagery capabilities. Thank you.
Thanks, Tadas. Another example about creating digital twin. Esri is continuing to implement machine learning and deep learning in core technology. And you have seen Donatas applying machine learning techniques. One area where deep learning has done exceedingly well is the computer vision, or ability for computers to see. This is particularly useful for GIS because satellite, aerial, and drone imagery is being produced at a rate that makes it impossible for analyze and derive insight through the traditional means. That means persons are unable to review the imagery, information, and extract it. So we should think how to process it in automated way. Tadas, I know you've been experimenting a lot with the deep learning, and I know that you are researching how it can be applied to GIS. Can you show the results of your experiments?
I sure can. So, deep learning has been a part of ArcGIS for a couple of years now. Each year it becomes more accessible and user-friendly. One of the new ways you can experience deep learning is by using the new interactive object detection tool in ArcGIS Pro. So let me show you how it works. So in this case, I'm using the same mesh data that you saw before in my previous demo. It comes from Vilnius Planas. And if I go to Analysis tab, we have Exploratory Analysis Tools, and we have this new object detection tool. So this tool takes a deep learning model as input. It could be a model that we've created ourselves, or it could be a model from Esri. In this case, I will use model from Esri for window and door detection. So let's say I wanted to detect windows on this building here. So let's zoom to the building. So I'll select window class and just run the process based on my current camera location. As you can see, as a result, we get these 3D points. So these points can be used for inventorization purposes as well as for 3D analysis. One such analysis is line of sight analysis. On the building next door, we have a 5G antenna. To ensure a strong 5G signal, we need to have a direct line of sight. So I actually used these 3D points to calculate lines of sight. And this is the result. As you can see, some of these lines are obstructed by different objects. To make it more clear, I have transferred the attributes from lines to points, and this is the final result. Looking at this result, I can assume that where we have these green points, we will have the strongest 5G signal. Another way you can experience deep learning is by using pre-trained models from Living Atlas. So Esri has prepared some models for you that you can use with your own data, and these include, for example, building footprint extraction, pixel classification, point cloud classification. Each model page has detailed information about how it's supposed to be used, what are the input requirements, what are applicable geographic regions, and so on. So I've used a few of these models, and I would like to share my results with you. The first example is building footprint extraction. So in this example, I'm using detect objects using deep learning tool in ArcGIS Pro. For model input, I used the building footprint extraction model from ArcGIS Living Atlas. For raster input, I'm just using World Imagery Service from ArcGIS Online. This specific place here is actually southern part of Pärnu in Estonia. So when I run the tool, I get this result. As you can see, most of the buildings have been detected. So even though the model itself was trained on data from United States, it still works quite well in Pärnu. Another example is pixel classification. In this example, I'm using Sentinel-2 data over Ventspils in Latvia. And once again, I used a deep learning package for pixel classification, specifically for Sentinel-2 data, which classifies it to coordinate and cover classes. And this is the result that I get. So when I have this result, I can also create a bar chart that shows us the distribution of classes. Last example from Living Atlas is point cloud classification. In this case, I'm using Lithuanian National Land Service data. This specific data set did not have power lines classified. So I used the power line classification deep learning package from Living Atlas, in addition to new ArcGIS Pro interactive power line classification tool. So let me show you how that tools look like. If I select a few points on the power line, this tool automatically detects the rest of the points on the same power line. So when I classify the power lines, I get this result here. You can see these green points, sorry, yellow points, which are power lines. In addition to that, I also used one tool called Extract Power Lines from Point Cloud. So what this tool does, it creates a 3D line, and the result looks like this. We can use this 3D line for analysis. So for example, we can analyze vegetation encroachment. So I can create a 3D buffer around the line. This is the buffer. And I can see which vegetation points intersect the buffer. And I actually extracted the points that intersect the buffer. And these are the points. So when we identify the places, we can send field crews to check these places and maybe trim the trees or bushes. We also have a lot of new models with ArcGIS.Learn module. We have models like CycleGAN, which allow you to translate from one type of imagery to another. So for example, it could be used to translate from SAR imagery to RGB imagery and vice versa. And I would like to show you one model. It's for change detection. So in this case, I'm using Sentinel-2 imagery over Lithuania. I have two images, one image before change, one image after change. The specific change that I'm interested in is forest cutting. So if we just look visually, you'll notice that we have some areas of forest that have been cut. To detect these areas automatically, I used this change detection model. It requires a few lines of Python code. It takes as input 3 images, so an image before change, image after change, and then a raster mask which shows where the change has happened. When I run this tool in ArcGIS Pro, I get this result, which visually shows us the areas where there's possible forest cutting. I can also quantify this result, and I can tell you that, for example, in this region here, we had around 1,000 hectares of forest that has been cut. So that's all for deep learning. Thank you.
Thank you, Tadas. That was really, really, really impressive. As you've just seen, ArcGIS is rapidly evolving. It's not a GIS I've learned when I started my career in GIS. It's integrating many new innovations in data measurement, in computing, and also in science. Esri is integrating new data sources from drones or from satellites or from other technologies, integrating new tools for computing, faster machines, also artificial intelligence, machine learning capabilities, the ability to support cloud-native environments with Kubernetes, and so on. ArcGIS by design is an open platform. That means it can be flexible, it can be extended in various ways, customizable. It's interoperable, using various standards and direct engineering technologies to make these things work together. Jack introduced this slide in the first day of our conference, and I want to put a bold statement here. The infrastructure, geospatial infrastructure, is already here. Interconnected infrastructure is already here. You have seen WebGIS interconnectivity in multiple scenarios. Use of base maps, geocoding, elevation data, feature services representing water utilities in ArcGIS Online, Autodesk products consuming this data, like elevation or base maps or feature services. This information was available on distributed devices like field operations devices. You have seen demonstrations about spatial analytics from a web browser using data sitting somewhere else, and the ecosystem of distributed services being brought together to empower these systems. As you can see, Esri is working on many products and initiatives to support your work. Esri will continue to do these innovations in incremental releases that incorporate the big development activities that are underway and as shown in a bigger sentences in this word diagram. So this concludes our presentation, and I would like to express my gratitude to the team members who were on the stage and behind the stage helping to make those demos, charted the uncharted software areas to create the demos you would like to see. Thank you. And now time to switch to the questions. Solus, do we have a lot of questions?
Yes, indeed. We have, as usual, a number of questions to be answered. So you need to look to the slider window. For those that really like to pose additional questions, please do it ASAP.
Okay.
But Vitas, you have a slider view now, and
yes,
the
finally.
most popular.
Okay, so question to Tadas. Which materials you would suggest to read to start using deep learning tools in ArcGIS? Your examples are really impressive.
All right, thank you. Well, if it would be possible, I could show it from my screen, some pages. If the operator could turn on my screen. Or if not, I can. Okay, thank you. So you can start with deep learning tips and tricks. So this will give you an introduction about hardware requirements that you need. Another option is to go to GeoAI landing page, which is a hub page. So you'll have some webinars here, Medium articles. You'll also have a link to demos. So it opens this page here. And these are videos that show you almost from start to finish how to go through different deep learning workflows. Another very good source is actually ArcGIS API for Python documentation. If you go to sample notebooks, there are a lot of sample notebooks for deep learning. So in these notebooks, not only you see the whole code, but you also are given sample data. So you can try it yourself with the sample data from Esri. And when you try with sample data from Esri, you can try with sample data from your own countries. So these are probably the best resources to start. This is where I learned. I don't have any special education or anything in deep learning. This is what I used to create my demos.
And supplemental questions here. Is ArcGIS Pro basic license is sufficient to run all kind of deep learning activities?
You need image analyst extension.
Yep. So image analyst extension is required to perform those deep learning activities. Okay, I see a question to Mindaugas. And Mindaugas, are you ready to respond to a question? How many GIS engineers work with utility network?
Hello. Yes, utility network, we have a project with a countrywide gas and electricity operator, ESO, and currently they expect to use more than 50 ArcGIS Pro users that will manage the data. So they will directly editing utility network, but there are lots of users that will use utility network from web application, mobile application. So that count I cannot say, but they will be, I guess, hundreds of users.
Okay, the next question is about how can I start using utility network, Mindaugas?
Well, you need at least deploy ArcGIS portal with ArcGIS server. So you need to have a utility network extension license as well, and ArcGIS Pro as a client. So these components, if you have these components, you can quickly start with the utility network. So the easiest way is to visit the Solutions ArcGIS.com site. So you will find lots of predefined solutions for customers organized in categories by utilities. So deploy one of your chosen solution and deploy from ArcGIS directly to your enterprise web.
Okay, and if I don't have ArcGIS Enterprise, but I have ArcGIS Pro basic standard, for example, can I have a single seat?
Yes, you can. And you don't need enterprise database as well. A utility network can be used with file database as well. So the easiest way to start would be to start from file database.
Okay, thank you, Mindaugas. Question I believe Nils could answer. We saw ArcGIS Hub and ArcGIS Sites. So is ArcGIS Hub Sites similar to ArcGIS Hub, or is it something different? Nils, can you respond?
Yes, hello to everyone. Well, basically, you get the same tools in ArcGIS Hub also as you have in Sites. Easily customizable environment where you can create your data portals. The difference is that ArcGIS Hub has extra capabilities like the community part, etc. And ArcGIS Hub is cloud-based software as a service, which means Esri will be maintaining it and upgrading it. ArcGIS Site is part of your ArcGIS Enterprise installation, which is on your own infrastructure.
Okay, thank you, Nils. Okay, the next question is for Tadas. I believe he already answered, but just to repeat, can you run LiDAR classification, Living Atlas deep learning models on ArcGIS Pro basic license? So with image analyst.
Let me just read it myself, okay. Here's the thing. You actually have to use notebooks to run this analysis. And theoretically, in theory, you don't need ArcGIS at all, because if you use, for example, Anaconda, there are two libraries that you need that are available publicly. So it's ArcGIS library and Deep Learning Essentials. Both are provided by Esri. If you use these two libraries, you don't even need ArcGIS. And you
ArcGIS Pro, you mean?
Yeah, even ArcGIS Pro. So it would be basically possible to run it just based on these libraries. Because the way I classified the point cloud in notebooks, so I didn't even use ArcGIS Pro.
Okay, so that was about 2.7. In 2.8, which is to be released mid of May. Today I installed the latest version, and they includes LiDAR classification into ArcGIS Pro. That's a part of ArcGIS Pro with deep learning, if you have it. Okay, I believe we answered. Okay. Will ArcGIS Velocity replace GeoEvent Server? No, it will not. And it will run side by side, so ArcGIS Enterprise, GeoEvent Server will run on premises. ArcGIS Velocity is a cloud-based solution. So it's a kind of extension to ArcGIS Online. Okay, and Nils wanted to respond about Estonian Transport Administration later on. So I believe this concludes all questions we had. So Saulus, I'm passing word to you.